So I'm very pleased to welcome Dr. Laura Braby. She's an expert on arguably the most exciting current in the ocean, our very own Agulhas Current. She will be sharing with us some information about its seasonal variability based on decades of observations that hardened oceanographers and salty sea dogs have risked their lives to get from a heaving ocean. It's one of the most energetic and treacherous parts of the global ocean. So I'm sure this will be really exciting. So her presentation is called Rough Seas, Never Before Seen Measurements of the Agulhas Current. And with that, I will hand over to you, Laura.
Cool. Thanks, Jenny. So today I'm just going to speak a bit about Seamester and a little bit about life at sea, and then what we've done with the data we've collected there. So these are just some photos from my time at sea. I think it's one of the major perks of oceanography for me. It's the travel that we've been able to do. We've been very fortunate to visit some incredible places. I think partially because of where South Africa is situated, but also because of the research vessels that we have access to. Nowadays, we have the Seamester program in collaboration with UCT and many other South African universities. It gives students an introductory to a variety of different marine sciences by giving them an opportunity to go to sea for 10 days where they get in classroom training and also practical hands-on experience of how to use different instruments across oceanography and a lot of biological sciences and all different disciplines. For the past 2 years, because of COVID, we haven't been able to go to sea, but hopefully this year in July, we'll be able to go again. I just want to play now a short clip from Seamester, but my computer was glitching a little bit, so I might have to just unplug it. Okay. Can you see the video?
We're not seeing the video, Laura. I think you need to share your screen again.
Is that okay?
Yep.
Okay. Let's reshare it again. Do you see my screen?
Yes,
Okay.
that's good, Laura.
Cool. So, yeah. So the one thing that Seamester provides for us is an opportunity to train students, but also to carry out our research in the Agulhas Current. Many of the Seamester cruises have taken place along the ASCA transect over here on the east coast of South Africa. It goes through the Agulhas Current. So ASCA stands for Agulhas System Climate Array. There was an array of moorings deployed there from 2016 to 2018. This figure on the right is what all the different moorings looked like. You can see an example here of the different instruments that were on it. The microcats, ADCPs, current meters. So it was in the water from 2016 to 2018 and gave us a lot of temperature, salinity, and current measurements. And so now for Seamester, we've had 3 Seamester cruises that visited the same transect. And instead of, now for the ASCA project, what happens is that we take a 20 station sampling strategy. So these 20 stations over here, and for every cruise, we sample the same 20 stations. Oceanographically, we use the CTD, which is this instrument over here. But actually, with the ASCA project now, we don't just look at physical oceanography, but we also do chemical analysis of seawater, look at biogeochemical parameters, ichthyoplankton, microplastics, marine bacterial, mammals, seabirds, marine meteorology, and also benthic dredge sampling. So really, these cruises enable us to take a very multidisciplinary approach and really try to understand the environment better. One thing about Seamester is that it always takes place in July in the middle of winter. This is great because we have very few measurements of the Agulhas Current during winter, but the seas can be quite rough. So this is just a synoptic chart from one day of the cruise in 2019. In 10 days, we experienced 3 cold fronts. So this little ship is where we were. And I just see if I can play this. So it was really quite rough, and I think we did quite well to be able to sample 16 out of the 20 stations in those days, given like how rough the conditions were. I actually, I don't know if I can. Sorry, I need to share it again. My computer's being a bit glitchy. Sorry, that should be the last time. You see the top screen, right? Okay, so I wanted to read it just, it's a bit of a silly thing, but I wanted to read a little, just a short paragraph from the cruise report from this day. I think it was, what is it, 6th of July. At the start of Station 13, it was decided that the weather had picked up too much and would start becoming detrimental to continue CTD operations. A halt on the work was initiated at 19:30 ship's time until the weather improved. The swells picked up to 8 meters through the night, with winds in excess of 50 knots at times. The vessel slow steamed into the weather from station 13 and only attempted to turn around in daylight hours to slow steam back to position again. Damage from the storm included a missing cod end from the oblique bongo, a dolphin and seal carcass washing over the side, a computer in the ops room having fallen to the floor. Yeah, the conditions were pretty rough, but for the CTD, we're quite lucky that it's quite robust, and we were able to still finish 16 out of 20 of the stations. Yeah, so this asks the question, why do we go to such extreme lengths to study the Agulhas Current? Especially in like these type of conditions. So we're going to look a little bit at the importance of the Agulhas Current. So the Agulhas Current is a western boundary current. So it's on the western boundary of the ocean basin. And western boundary currents are known to carry heat polewards, moderating the Earth's climate. And this could either exacerbate or mitigate warming and extreme weather events in the future, depending on their response to climate change. And we know that the Agulhas Current is the strongest western boundary current in the southern hemisphere, and it plays an important role in the exchange of heat. So this is a figure of temperature, heat and salt exchange between the Indian and the Atlantic Ocean, predominantly through these Agulhas rings over here. So the Agulhas Current really has an impact on global climate. It also has a really defining role on our regional climate. We get very high rates of evaporation above the Agulhas Current. And yeah, it has a significant impact then on our rainfall. The temperature of the Agulhas Current and its proximity to the coast also affect our rainfall. And yeah, it's been shown to have a big impact on extreme weather like flooding and storms too. But it can intensify them. So typically the Agulhas Current flows closely along the coast, but sometimes the Agulhas Current can meander, so it really deviates from the coast in this kind of cyclonic circulation. And when this happens, we get cold water that can upwell in the middle over here, which is like a cyclonic eddy. It's nutrient rich, but it also can mean a current reversal up the coast here instead of the traditional poleward flowing current over here. So we get meanders in the current that are called Natal pulses that happen a few times a year. And this has an impact on some of our South African industries, namely the fishing industry, because of the upwelling of the nutrients, and then the shipping industry. And then it also has the potential to impact the renewable energy industry should we ever decide to extract power from the Agulhas Current. Okay. So in the past decade, we've learned quite a lot about the seasonal cycle of the Agulhas Current, but we still have quite a lot of questions. Observations of the Agulhas Current show that the current is stronger during summer. So this figure over here shows transport, and then these are the different months over here. So it's a bit, so the more negative, the stronger the transport, because the current is flowing southward. So in summer we have a stronger transport. The gray here there's two different estimates of transport. So gray is the more traditional one, but both show that the Agulhas Current is stronger during summer. So that is seen in both in situ observations and as well as in the altimetry, but it's really difficult to capture in numerical models. Most of them have not been able to get this correct. We also, besides the currents, we also know a little bit about how the temperature varies. At the surface, we have warm waters in summer, cooler waters in winter, consistent with the higher net radiation during the summer months. But deeper, we know that the seasonality is reversed with cooler waters in summer. But there's still a lot that we want to know about the seasonality of the Agulhas Current. So now we get to our science, where we use the first full depth observations of the Agulhas Current during winter to try and explain a bit what is happening with our water masses of the Agulhas Current. So we're going to try to further characterize the seasonality of the Agulhas Current and its water masses using 8 hydrographic cross sections of the Agulhas Current, all collected along this transect over the course of 10 years. And compared to mooring data, this data might seem very sparse, but it is a lot higher resolution than the mooring data. The vertical resolution is an order of magnitude better, and we have 20 CTD stations as opposed to the 9 mooring sites. I think there's also large sampling gaps in the mooring data. So we just use this to get a clear picture for the eight cruises that we have of what the Agulhas Current looks like. So just to explain a little bit about water masses, these are different water masses that we get in the Agulhas Current. They're named from where they come from, so tropical surface water, it comes from over here, subtropical surface water, South Indian central water. Okay, so these are surface water masses, and then Indian central water and Antarctic intermediate water, more deeper down. So Antarctic intermediate water, Red Sea water, and then we also get North Atlantic deep water over here. Okay. North Atlantic deep water can be split into 2 layers, upper and lower North Atlantic deep water. Yeah, the lower North Atlantic deep water is usually farther downstream, enclosed by like the regional topography. And then to distinguish between different water masses, we can look at a property called neutral density. But neutral density is very similar to potential density, but also just it takes into account the latitude and longitude, so the specific location. Okay, these are our 8 cruises that we have, and these 3 cruises, 2016, 2018, 2019, July, were Seamester cruises, and they are the first 3 full depth winter cruises that we have. And then if we look over here about what's interesting about the state of the current, this cruise in 2010, there was a meander, but all of the other cruises, it was the normal state of the current. It just means that when we look at statistics with such a small data set, we don't really want the meander to skew our results too much if we include it in our stats. Of our 8 cruises, we have 5 full complete cruises, 3 of them in summer and 2 in winter. And then for the Seamester cruises, these 3, we have SADCP data. So there's the lowered ADCP, which it attaches onto the CTD, which we get for these first 3 cruises, and then the rest are ship ADCP. So that is an ADCP which is mounted to the hull of the ship, but can only measure to maximum about 650 meters depth, whereas the lowered ADCP goes all the way down with the CTD, so you get the full depth column and of velocity. So for our Seamester cruises, we had to use the ship ADCP data, which is this blue line over here. So I think you can see it doesn't quite reach 600 meters, but we want to know the velocity of the entire water column. So we were able to use the temperature and salinity data from from the CTD to calculate the velocity throughout the full depth of the water column. Okay. We also use satellite sea surface temperature data to give us some context of what the current looked like during each of our cruises. Yeah, so it gives us more information about what's happening upstream and offshore. So this is the first cruise in April 2010. Here you can clearly see the meander over here. When we look at the winter cruises, we see quite a cold temperature relative to the summer ones, and very, very cool temperatures inshore here. There's also an eddy offshore here and another one upstream. Like you can see the, I'm going the wrong way, cyclonic circulation over here. Clockwise. Okay. So when we compare the CTD data with the satellite data, it helps us to develop confidence that we can estimate seasonal signals from the very few hydrographic surveys that we have. So the orange and red line represent summer months for the satellite data in orange and the CTD in red, and we see that they actually compare quite well. And then we have the two winter comparisons here in blue and black. The biggest place where they differ is in the region closest to the shore. So this is the distance offshore. So that is a known problem in satellite data. They often data is not great near to the coast, but we also have a lot of cloud cover in the region, which can impact the results. But overall, the really good comparison between the data gives us quite a lot of confidence that the results that we have, we can consider as seasonal. So earlier when I was speaking about the velocity, if we were to look at a cross section of the velocity, so this gray here is the topography, yeah, the seafloor, and then so these two figures on the left are cross-section of the velocity during winter, and these are cross-section of the velocity during summer. And from the literature, we know that we expect stronger velocity during the summer months. So that's these figures on the right. So on average, if we look at all the transport, we get a stronger transport during summer, which is not new, it's what we already know. But yeah, I guess one difference between the summer and winter here is this offshore equatorward velocity over here. Okay. To explore seasonal changes in the distribution of each water mass within the Agulhas Current, we created masks using those neutral density values to try and understand the differences between all the water masses that we see on each of the surveys. So we stopped looking at the meander survey because we get such different water masses there that we don't want to include it because it would confuse our understanding of the seasonality. So the most notable difference in these figures with the summer cruises on the left and the winter cruises on the right is the upwelling of this yellow water mass over here, the South Indian central water onto the shelf during summer, but not during winter. So this upwelling, yeah, is clear in the summer transects. Yeah, so this upwelling doesn't outcrop at the surface, so we call it cryptic upwelling. It's not visible by satellite data, and so therefore it's largely unobserved. One implication of this upwelling signal is that in the depth average, the waters of the shelf at this latitude are cooler during summer than winter. despite the stronger insolation during summer. So this cool, oxygen-rich and nutrient-rich water that upwells onto the shelf will have ramifications for productivity, recruitment, and ecosystems in these shallow euphotic waters. If we just look at differences between temperature and salinity, so the top is temperature and salinity between summer and winter, we see that there's quite a lot of change. This figure, it has a lot of information in it, but if the left is just a normal transect with depth, and then on the right, instead of looking at depth, we look at changes in the neutral density. So it's just more clear to see the changes in the different water masses rather than just with depth. Helps us to understand what's truly a seasonal change and as opposed to heave. So we can see the clear difference here. This at the surface, the waters are warmer and fresher during summer. That's to be expected and has been shown before. We see the cooling over here in the region subsurface, but also we see the warming on the offshore flank of the Agulhas Current. It's important to look at if these changes are also observed in neutral density space. We see that here, but not so much in this red box over here. Okay. If we sum together the transports of each of the different water masses, we can see some differences in the seasonality. The biggest, so all of the water masses have a stronger transport during summer compared to winter. And then the direction of the North Atlantic deep water, which is the red lines, changes from summer to winter. So if it's above 0, that's equatorward direction, but where normally or during summer, it flows in the poleward direction. So all of these are poleward direction, whereas in winter, the North Atlantic deep water, which is the deepest water mass, we observe some equatorward flow. So just want to, this figure, just to summarize what we'll be seeing, some changes between summer and winter in the water masses. So in summer, we see this yellow water mass over here. The central water mass upwells onto the shelf during summer only, but not during winter. Below the seasonal layers, water in the Agulhas Current are cooler during summer due to the upward tilt of the isopycnals. And then during winter, we see the equatorward flow of the North Atlantic deep water sometimes, whereas in summer, we just see the poleward flow. So from a relatively small data set, we've been able to see quite a lot about what's been happening in the Agulhas Current. And hopefully this year we'll be able to go again to build up our data set even further. But definitely in the Agulhas Current, we need more in situ measurements to really understand the seasonality of the current. Cool.
Thanks so much, Laura. That was really interesting. And, you know, you gave us a really good sense of how difficult it is to do science in the marine offshore region. You know, apart from it just being extreme conditions to deploy your instruments, it's vast, it's deep, it moves a lot, and that's a lot of information to synthesize. You know, we need big data to study the marine offshore region. I'd like to open the floor to questions. You can either post your question in the chat, or I prefer it if you raise your hand and put your video on if you're able. Anybody? I do have a question, but I'd like to not be the first one. Okay, I'll start. Laura, so I know why the Agulhas is important from a global perspective and, you know, from a very regional and operations perspective. But from a seasonal point of view, why do we care about the seasonality of the Agulhas?
Well, it's interesting because we don't understand it, but also because it has such a big impact on our weather. I think, you know, on the East Coast, you receive most of the rainfall during summer, and also flooding. I think to better understand that is important. Yeah, I'm sure there are many other reasons, but yeah.
Remember last year there was that marine heat wave.
Yeah.
It was a marine heat wave, and do you think the Agulhas has an important role to play in events like that, in more episodic extreme coastal events?
So that, if I remember correctly, there was a marine heat wave followed directly by a meander. So the water was really warm, and then because of the meander, there was the cool cyclonic eddy with the upwelling straight after. So because of the huge change in temperature, I think a lot of fish species couldn't cope with that. What was the question? Is how the Agulhas?
Yeah, I mean, so the Agulhas obviously had a role to play because that was an Agulhas meander.
Yeah.
So the Agulhas meanders, do they have a seasonality?
No.
Okay.
Not that we know of.
Okay. Thank you. Any more questions? In the chat? I can't. Oh, Gustav has a question. Please go ahead, Gustav.
Hi, Laura. I assume that thing is going to happen this year. What you call it? ASCA. Not ASCA. The Seamester.
Sorry.
Is Seamester going to happen this year then?
We really hope so.
Okay.
Yeah, it's in the plans. I think it just depends a lot on if we would have to quarantine before or not, because it's not really feasible for 100 of us to quarantine for 2 weeks before the cruise. So yeah, but it's still really hope that it will happen.
Oh, cool. And then I just wanted to know the sampling. When you go normally, you said that you guys are doing 22 samples, I think, of CTD costs, or 20.
Yeah.
Do you guys do it from is that like one coast and then you guys kind of move offshore, or does it start offshore and then move towards the coast? I'm just curious because I need to ask you for coordinates, but I just haven't gotten there.
It usually starts at the coast and then moves offshore, and then if at the end of the cruise, if the weather's been good and everything's gone towards plan, if there's more time, then you can do another transect back in. I guess it also depends on if moorings are being deployed and not, because often you'll do a CTD cast with that. But yeah, usually from the coast out, and then if there's time for more, then back in.
Okay, cool. Okay, that's all I wanted to know. Thank you.
Where does the Agulhas Current officially start and end? That's a big question. It's very hard to answer. If I put I don't know if my map will go. The Agulhas Current starts somewhere over here. We don't know the exact location. It's something that I really would love to know. But we get a lot of eddies which propagate into the northern Agulhas Current from the Mozambique Channel and also from south of Madagascar. And it's a lot of people want to know, where do the eddies end, or where does the Agulhas Current officially start? And then in terms of where the Agulhas Current ends. So the current, the other figure was better. So the current retroflex here, south of South Africa, and then it flows back, and we call that the Agulhas return current. So maybe, yeah, so if you want it, depends on if you distinguish that as a different current or not.
I think the answer is, how long is a piece of string?
Yeah.
It kind of starts in a turbulent manner and then it kind of ends in a turbulent manner. And there's a section where it's much more cohesive. Laura, since I don't see any more questions, but I don't know, do you want to share with everybody your friend who is swimming?
Well, Christina is also here, but we've been working with a lady called Sarah Ferguson, who is also my friend. She is a retired national swimmer, but now she is an endurance swimmer. And she's done some really impressive swims, across, like one across a channel in Hawaii, where she got stuck in a very strong tidal current for hours and hours. And then she's done another one circumnavigating Easter Island. I think she was the first person in the world to do that. But now she's going to attempt to swim from Durban to Cape Town. And she wants to use the Agulhas Current as much as possible. And I think she'd like to break the 100-kilometer record for the fastest swim. So Christine and I have been meeting with her a bit to try and help her understand like things that could happen, like if there would be a meander on the day, and how the current could vary, how maybe she could get really rough seas, like the video. So it's quite a scary swim. She's very brave.
Indeed.
Christina's just written a newsletter article on it, so it should be out.
Yeah. Hi guys. Sorry, my internet cut out while Laura was explaining the swim, but it's very exciting, and it's like the biggest swim she's going to do. It's longer than the drive from Cape Town to Joburg.
Cool. Well, stand by for the newsletter article. Thanks everybody. Thanks Laura. I just want to advertise next month's presentation, which will be on the 4th of March by Rowena Harrison from Grasslands. And her presentation is on gaining insights into the hydropedological characteristics of 3 Afro-montane catchments. So we hope to see you all there. Thank you. I think that's all I had to share. Thank you, Laura.